I'm gonna record now. Okay. So we reviewed the very beginning. The last part was on your video. And now we're going to move on. And hopefully this next part kind of helps clarify what we were just doing. We are now taking, or essentially going backwards. I'm going to give you like the expanded out version and we're going to condense it down. So your answer is simply going to be sine of a number, cosine of a number, tangent of a number. So we have to take what we know about the formulas and be able to identify what like these drawn out, expanded out parts are. So number 2A says sine of 58 cosine of 32 minus sine of 32 cosine of 58. So I'm going to my identity sheet and I'm seeing which one looks like that. The only one that looks like that is the one that has sine times cosine and then sine times cosine, which is the first one. It's my sine of alpha times cosine of beta, etc., etc. That means I'm going to do sine. The other thing that matters is I'm going to worry about sine, and I have 58 and 32, but I care about what operation goes in between those two. Remember in sine, I told you that the signs match. So the plus, the negative, whatever I was given or whatever's in the formula matches. So if this formula has a minus sign, then that means that this is going to be subtracted between them. Yep. The sum and difference? Yeah. You're welcome. Is that big enough? Okay. Okay, so I use that, and now I can actually do what 58 minus 32 is. So that makes it going to be sine of 26, I believe. Yep. And that's my final answer. I should throw a little degree sign there. That's most correct. All right, that's all it is. So I'm taking expansion, I'm condensing it down. Anybody questions yet? We've got 4 more like that. Since I see B and C already, I'm just going to do those. If I look at B, it says tan of 13 plus tan of 18, all divided by 1 minus tan 13, tan 18. Which one does that look like of my sum and difference? Tan, right? The only one that has tangent in it at all is the tangent one. And it looks just like it. Tan of something plus tan of something else, all divided by 1 plus or minus tan of both things multiplied together. So this is going to simplify to be just tangent. And I'm going to have 13 and 18. And I care about how I combine them again. Just like in sine, my numerator, the signs match what's given to us. So if we have a plus on the top, then that means that I'm going to have a plus in between those two. Remember that the minus plus, and I know, bless you. I know that was something weird I introduced the other day. The minus plus means that whatever is given to me, I want to do the opposite of it. So if a plus is what's given to me, I'm going to do a minus. If a minus is what's given me, I'm going to do a plus. So that means the opposite. So since there's a minus on bottom and a plus on top, we have to match the top and go opposite the bottom. So I'm going to do tan of 13 plus 18, and I can do 13 plus 18. I believe that's 31. You can put parentheses or you cannot. I realize I'm a little willy-nilly about it. It's just whatever is your preference. So if you like parentheses around your angle, keep putting them. If you don't care, I don't care either. Okay. Next one, cosine of 12x times cosine of 9x minus sine of 12x times sine of 9x. What are we thinking? Which one does that look like? The second one, right? Because the cosines go together and then the sines go together. So since the cosines go together and the sines go together, we're going to match cosine. So I'm going to do cosine of 12x and 9x. But I got to figure out, am I adding or subtracting those two? Remember that in sine or in cosine, they are opposite. So we're going to do a plus. Very good. So we're going to do a plus. So 12x plus 9x is going to be 21x. And again, there's really no rhyme or reason to why I put parentheses around the second two and not the first one. I just felt like it. It's right either way. Okay. Letters D and E got cut off a little bit, so I'm going to have to kind of rewrite them for you. So D should say sine of 6, sine of 10, minus cosine of 6, cosine of 10. Which one does that look the most like? The second one, I like that we thought the first one at first, and then we're like, no, wait, the sines go together and the cosines go together, so it's like the second one. However, in order for us to use the second one, we need to flip them so that cosine goes first. So I need to rewrite this. I need to move the negative cosine 6, cosine 10 to the same side, and then I've got a plus sine 6, sine 10. But if you see in my formula, we don't have a negative in front of my cosine, so I have to factor that negative out. So I got -1 times cosine of 6, cosine of 10. That makes my plus a minus sine 6, sine 10. I just had to flip them, and then I had to take the negative out because I don't want a negative out in the front of my cosine. That just means I'm going to take my answer and multiply it by -1. And so I'm going to do -1 times cosine. And I'm going to take my 6 and my 10. And am I going to add those together or subtract them together? Add them. Very good. Opposite signs. So I'm going to do cosine of 6 plus 10, which is going to be 16. I need more space. So it's going to be negative cosine of 16. That's my final answer. And again, degree sign is best practice. I think that one was the most work, and all we had to do was just switch it and factor out a negative. So just a little bit more work than maybe we were doing before. All right, now I've got to rewrite this one just because you can't see it. So that's sine of 37, cosine of 19, plus cosine of 37, sine of 19. And which one does that look like? The first one, good. So sine of 37, cosine, whenever you have the sine and the cosine go together, and then the sine and the cosine go together, that is a sine. And am I going to add or subtract 37 and 19? Add, good. The signs need to match for sine, so I'm going to add them. That gives me sine of 56. I'll zoom out in a second. I just am writing really terribly today, so. All right. Anybody questions or concerns yet? Okay. Let us move to the next side. We're just going to do 2 on the next side. I don't want to do letter B, but we will do A and C. And that's kind of bringing back into play the 5.2 stuff where we're verifying. So again, I need you to just pick one side of the equation. We're going to simplify that. And we're going to probably use one of the identities that we just learned this time, one of the sum or difference identities, in order to verify. So let's zoom in on number 3. I've got sine of x minus pi over 2 equals negative cosine. Okay, I believe sine of x minus pi over 2 is the more difficult side. And that matches what we've just been learning. We've been doing sum and difference problems. So we're going to use the first equation. We're going to use sine. Instead of a plus or minus b, it's going to be x minus pi. So we're going to use this first formula for that. So sine of x minus pi over 2. Okay, so I've got to do sine of one times cosine of the other. So sine of x times cosine of pi over 2. Since there's a minus in my equation, there's going to be a minus separating my sines and cosines. And then I'll do sine of the other one times cosine of the other one. So sine of pi over 2 times cosine of x. Okay, so all I did was I took sine of an angle minus another angle and I expanded it out using my sum and difference. Okay, now we don't know what sine of x is, but I do know what cosine of pi over 2 is. If you don't remember, we can use our unit circle. What's cosine of pi over 2? I don't think so. What angle is pi over 2?
90.
90. Okay, what's my x at 90? 0. Okay, I'm so sorry if someone said that. I didn't hear you. Pi over 2 is 90. Cosine at 90 is 0, okay? Now we're going to do the same thing. Now we're doing sine of pi over 2, which we've already established is 90. What's my sine at 90? 1. Cosine of x. That's helpful because now I've got numbers involved. Sine of x times 0, well, that's just 0. And -1 or minus 1 times cosine is just cosine, so I've got minus cosine. And 0 minus cosine is negative cos. And that's awesome because that's what I wanted. We did it. So by plugging in, because we were able to use pi over 2 and actually use numbers there, we plugged in some numbers and we were able to simplify it down to negative cosine. We good on that? All right, I got one more of these and then we're done with this section and we'll just move into 5-4. I'm going to kind of be quiet. I want you guys to try this. You have two sum and differences. We have sine of x minus y. So we're going to use the sine plus or minus again. And then we've got sine of x plus y. Can you expand both of those out separately and see if we can combine or cancel? Sine of x minus y. See if you can expand those out or cancel. And I'll do it up here so you can watch me, and I'll do it in different colors so you see which one I'm looking at. Once you've expanded both sides, check with me, make sure you expanded correctly, excuse me. And then if you can, combine any like terms. If you can, cancel any terms. I have two pieces that are sine x times cosine y. I highlighted those in green. And then I've got one term that's negative sine y times cosine x. And I've got another one that's positive sine y times cosine x. And those were able to cancel out. So I'm just left with 2 sine x cosine y. We did it. All right, any questions so far? Okay, that is all of 5.3. So as of now, that homework is due next time I see you, which is tomorrow. We're going to get into 5.4. Anybody need anything in the meantime? I've got 2 more types of identities to teach you. So the next part talks about half angle identities. Something that it doesn't physically say in the directions, but we're going to use are double angle identities. So why don't we go over those first, and then we'll start using them. I don't think these are as like common or understandable, or I can't really like derive it for you right now. So we just kind of have to, you know, trust and believe. But that's also why they're on our identity sheet. So half angle identities. That means I'm going to do sine of an angle divided by 2. I'm going to do cosine of an angle divided by 2. and I'm going to do tan of an angle divided by 2. I think the double angles make a little bit more sense. I feel like I can explain how we derive them a little bit better, but half angles, we just kind of have to trust and believe. Okay, sine of x over 2 is going to be plus or minus a big square root of 1 minus cosine x over 2. All of that's under the radical. All of that's under the radical. Okay, cosine is very similar, literally almost the exact same, but instead of 1 minus cosine x, it's going to be 1 plus cosine x. All of that's over root 2. And then tangent is a combination of them. It goes plus or minus a big radical, and it's going to have 1 minus cosine x on top and 1 plus cosine x on the denominator. So take a second, copy those down, take a picture if you need to. Those are the next things that we're doing. All right, anybody questions yet? All right, can I do the double angles now? Or are we still doing half angles? I'll keep it here for one more second. All right, here come the double angles because I feel like we're ready for them. Those papers aren't important. Okay, so double angles will go right here. Yeah. You might need it for the last one. Yeah, you can use it. Double angle theorems are if I'm doing sine of 2 times something, or cosine of 2 times something, or tangent of 2 times something. Sine and tangent are very similar to the addition, to the sum and difference one. Sine of 2x is the same thing as 2 times sine of x times cosine of x, which I want to kind of expand out. If you remember, this sine of a plus b has a sine of a times cosine of b plus sine of a times, or sine of b times cosine of a. But if we happen to have the same angle, so if a and b were the same, that would be sine of something times cosine of that same thing plus sine of something times cosine of that same thing. So if I was to have the same angles for a and for b, then it would simplify down to here. So I think that's kind of cool and interesting. Tangent is very similar. Tangent is going to look a lot like its sum and difference one. Again, we're just going to be multiplying when I can or squaring when I can. So tan of 2x is going to be 2 tangent of x over 1 minus tangent squared x. So again, I think that looks a lot like what we were doing with the adding and subtracting. Now, truthfully, cosine might feel the most difficult because there are 3 options here. But that's kind of nice sometimes because it lets you use what's most helpful. Give you a second to make sure you have that done. Okay. So cosine of 2x could be cosine squared x minus sine squared x, which again, I'll zoom out and I would argue it looks a lot like the cosine, bless you, and sine sum and difference, because I've got two cosines together and I've got two sines together. Again, if A and B are the same thing, then when you multiply them or when you combine them, it just becomes squared. However, we could break this apart using like our Pythagorean identities, and we could make it also be 1 minus 2 sine squared x, or 2 cosine squared x minus 1. Just kind of giving you all the options, because sometimes we'll want one and sometimes we'll want another one. I'm going to make sure these are highlighted because those three go together. So these are essentially all the identities we've learned in 5.3 and 5.4. Make sure you have those written down or take a picture of them. I understand we don't quite know what to do with these yet, but does anyone have any questions? Yeah, as of now. All right, let's get back into our notes. Let's swing back to that. We are going to do 2 half-angle formulas. So I'm zooming in. I'm focusing on my half angles because I know that I have to deal with that. Oh, that's not what I wanted. It's fine. I just switched the field. So I'm looking at cosine of 15. We did this using our sum and difference, but now I want to use it using our half angles. Because what divided by 2 gives you 15? 30. And 30 is on your unit circle, right? So that's why we are going to use our half angles here. So I'm thinking this is cosine of 30 divided by 2. So 30 is my x that I'm going to use. That's this x right here. So I'm going to use the identity I just taught you. I'm going to write this as cosine of 30 divided by 2 is the same thing, or equals plus or minus square root of 1 plus cosine of 30 all divided by 2. Okay. Say again. Every angle that we use will be a special one. I'll teach you another method tomorrow, but as of right now, the angles we're going to be using are special ones. So I know what cosine of 30 is, right? Can you remind me what cosine of 30 is? Root 3 over 2. We'd love for it to be 1/2, but life's not that easy. So I replace cosine of 30 with root 3 over 2. We're going to simplify this a little bit, not a ton, but we're going to simplify it a little bit. And we'll start by simplifying that numerator. We're going to combine 1 plus root 3 over 2. 1 is the same thing as what with a fraction? How can I make those have like denominators? 6 fine. 2 over 2. So if I think of 1 as 2 over 2, then I can do 2 over 2 plus root 3 over 2, which is just going to be 2 plus root 3 all over 2. We have to remember we've got this big, giant, ugly fraction. But we've gotten used to dealing with that. We can get rid of that big, ugly fraction by multiplying by the reciprocal. If I'm dividing by 2, that's the same thing as multiplying by 1/2. So that's going to give me 2 plus root 3 all over 4. And we're actually almost done because do you know the square root of 4? 2. So that's going to be plus or minus root 2 plus root 3 all over 2. Now, I didn't mention this in my other classes, so I'm going to need to remind them tomorrow. But the plus or minus only helps me until I know what quadrant I'm in. What quadrant is 15 in? 1. Is cosine positive or negative in quadrant 1? Positive. So I could actually get rid of that whole plus or minus because technically it's going to be a positive value. So I don't need to put that there anymore. This is a good enough answer. That's good. It's a square root of 2 plus root 3 all over 2. It's kind of messy because you've got a square root inside of square root, but that's going to be good enough for now. Okay. All right, we've got another one like this. It says tan of 67.5. So I got to ask myself, okay, tan of what number divided by 2 gets me 67.5? What'd you say? I think 135. If you do 67.5 times 2, it will tell you what number that is, and I believe it's 135. All right, so we got to use the tangent one now. So tangent of x, which is 135, I've got to do cosine of that and cosine of that. Before we get started, what's the cosine of 135? It's a cosine of 135. I think I heard it. I heard root 2 over 2. Is it positive or negative, though, in that second quadrant? Negative. Good. So that's an important thing to know. I'm going to be plugging that in momentarily. I'm going to start by setting up my big equation, and then I'll plug instead of cosine of 135, I'll put that negative root 2 over 2 in. 1 minus cosine of 135 over 1 plus cosine of 135. And you just told me that cosine of 135 is negative root 2 over 2. So I'm going to plug that in wherever I see cosine of 135. I just want to simplify it down enough that I have no extra denominators in here. So we have to combine the numerator, we have to combine the denominator, and then we'll multiply by the reciprocal and hopefully cancel something out. Okay. So a minute ago, you told me that 1 could be rewritten as 2 over 2. So we're going to use that concept here. Both of those 1s are going to become 2 over 2. And I'll even write this step out. You don't have to write this step out if you feel good, but I can write 2 over 2 minus a negative becomes a positive root 2 over 2. And then 1 plus negative root 2 over 2 becomes 2 over 2 minus root 2 over 2. Lots of 2's, lots of roots. Be careful with your stuff. Again, you might not choose to write this step out because you might go directly to just 2 plus root 2 all over 2, and then 2 minus root 2 all over 2. And that radicals over all of that ugly fraction. Okay. I can't simplify anymore besides multiplying by the reciprocal, so I'm going to multiply by 2 over 2 minus root 2. So I'm taking the denominator, I'm multiplying by the reciprocal. I'm going to do that right here. So in that case, my 2's cancel, and I'm going to leave this as plus or minus, which we'll get rid of in a second, 2 plus root 2 over 2 minus root 2, all under that radical. We could definitely simplify it more. I just don't feel like doing that more today. That's good enough for right now. my last question to you is, if we're talking about an angle that is 67.5, is that going to be a positive or a negative tangent? What quadrant is 67.5 in? It's 1, so it's going to be positive. So we actually can just erase that root or that plus or minus because it will just be a positive number. If it makes you happy, you can write a plus sign in front of it. I don't mind. You just don't need the plus or minus anymore. All right. Questions yet? We're going to do 2, 3, and 4, and then we're it for today. Am I on time? I'm doing okay, but let's keep rolling. If we get extra time, that's fun time at the end. Okay, we're going to take these concepts and we're going to fill in 2A, B, and C using either our half angles or our double angles, kind of depending on what we see. If I'm looking at 2A, I see 1 minus cosine of 47 over 2. Which one does that look like? Does that look like one of my half angles or one of my double angles? Looks like one of my half. Which one of my halves? Good, sine. So we're going to do sine of what divided by 2? 47. Mm-hmm. And then my last step is just actually doing what 47 divided by 2 is, which I have 23.5. Okay, any concerns on that? Okay, let's look at the next one. I've got sine squared of 87 minus cosine squared of 87. What does that look like? Does it look like one of my half angle identities? Nope. Does it look like one of my double angle identities? Yeah, it looks like this cosine one, but like not exactly there. Like it's almost there, but it's not exactly. Remember on the like a problem earlier today, we had to like change sides and then like factor out a negative. We're gonna have to do that here too. So technically, this is like negative cosine squared of 87 plus sine squared of 87. And when I factor a negative out of both of them, I get negative times cosine squared 87 minus sine squared 87. And that looks like my cosine. So we're going to do cosine of 2 times my angle, which is 87. So we had to flip it. We had to take out the negative. And then I had to take my 87 and multiply it by 2. Is that better? I never know if we want to see more or if we want to see bigger. So. All right, one more like this one. It's a tan, good. It's a tan double, and what am I doubling? Good, so I'm gonna do tan of 2 times 73, and so that's gonna be tangent of 146. So if we don't have to do any arranging, it's a pretty easy one, isn't it? Those are pretty easy types of problems. The problem is when we have to kind of move it around. Okay. We've got 3A and B. We're not going to do C. And then we've got 4A and B. So I've got essentially 4 more problems. These are using my identities, but also using the idea that we did back in 5.2 where we were solving for an angle. So my answers here are going to be angles. This is like the last problem that you took or that was on your quiz on Friday. So we're going to simplify, we're going to solve, we're going to get it all together, and then we're going to identify what angle makes that true. And in number 3, for these two, we're going to give us angles in degrees. So you may want your unit circle out if your unit circle is a little shabby. Okay. The only thing here is I have to use my double angle theorem to start solving. So for number 3a, it says sine of 2x equals sine of x. I'm going to replace sine of 2x with 2 times sine x times cosine x, this part right here. So that becomes 2 sine x cosine x equals sine x. Once I write it like that, this looks like kind of familiar to what we've done before, right? What do I need to do next? We're gonna have to deal with the cosine in a second. Let's move everything to one side. When in doubt, move everything to one side. So I'm gonna minus my sine x off of both sides. And I get 2 sine x cosine x minus sine x. Now what can I do? Got 2 times sine times cosine minus sine. Factor. What can I take out of both of those? The sine. Very good. Take the sine out. I got 2 cosine x minus 1 equals 0. Yeah, Ethan. Mm-hmm. I use the double angle theory to take it to that. I don't want to put it back into that because I can't factor anything out of those two. Because that's not like sine of it's not like 2 times sine of an angle. It's sine of like twice the angle. And those don't have anything in common. All right, so now I'm here and I'm ready to set both my factors equal to 0 and go. So I'm going to do sine x equals 0. And I'm going to do 2 cosine x minus 1 equals 0. And with both of those, we ask ourselves what angles give us sine of 0. What angle gives me sine of 0? 0. Yep. And 180. I ask myself what angles have a y at 0, have a y of 0, and a 0 and 180 have y's of 0. Now, the cosine one, we've got to simplify. We got to add 1 to both sides. We got to divide by 2. So I have 1/2. What angles give me cosine of 1/2? X has a cosine, has an x of 60 degrees, good. And then where's the other place that we would have a positive 1/2 as my x? Quadrant 4. And that angle should be 300, right? I know that was a tiny space. I hope you got it in. So if you did, flip your paper over. Yeah, 3 more. All right, I think the next one's probably one of the harder ones that we're going to do today. I've got cosine of 2x equals cosine of x. Just like we did on the last problem, I do need to replace cosine of 2x with one of my double angle identities. Now, which one is probably the easiest one, or which one should we use? 2 cosine squared minus 1? Yes, very good, Jaden. Why do we want to use that one and not either of the other ones? You what? Never mind, okay. If I were to use the first one, cosine squared minus sine squared, that would add a sine squared involved, and I can't factor anything out if I've got another trig function. In essence, I just really want one trig function in my equation, and so that's going to be my 2 cosine squared minus 1. So I've got 2 cosine squared x minus 1 equals cosine x. And this might not be obvious at first, but get everything to one side. So move your cosine x over. Now I have a factorable equation here. I personally can't really see it when it's written like this, so I have to rewrite it. I like to write it as 2x squared minus x minus 1. If I replace cosine squared x with an x squared, cosine x with just an x, I find that little pink equation way easier to factor. And multiplies to be 1, adds to be -1. I need a plus there, I need a minus there. I'm kind of speed factoring. Is that a concern for anybody? You guys trust me? Trust your own factoring? Yes, no, maybe? Sort of. So I rewrote 2 cosine squared x minus cosine x minus 1 as 2x squared minus x minus 1. And I was able to factor that to be 2x plus 1 times x minus 1, which I think is a way easier way of thinking about it. And now I just replace that x with my cosine. So I'm going to write 2 cosine x plus 1 and then cosine x minus 1. That's good for us because now I just have factors. So we set each factor equal to 0 and find out what angles make that true. So I'm going to set 2 cosine x plus 1 equal to 0 and cosine x minus 1 equals 0. Minus 1 from both sides divided by 2. I'm asking myself where cosine of x is -1/2 and where cosine of x is +1. Where's my x -1/2? Well, we just did +1/2. Those were the 60-degree angles. We just have to do in quadrant 2 and 3. So that's going to be 120 and 240. And then where's cosine or where's x +1? That's only at 0, right? Doing great. What questions do I have yet? Okay. I'm not going to skip letter C, so we just have 2 more. We're going to skip down to number 4. We're going to do A and B. I would argue the hardest has already happened. While letter A is going to use a factoring, I would argue it's very similar to what we just did factor-wise, so that's going to make it make sense. So I've got, the only difference here is I just want radians now. Cosine of 2x plus cosine of x equals 0. So I'm going to replace my cosine of 2x again with the exact same thing I did before. 2 cosine squared x minus 1 plus cosine x equals 0. And I should put it in order like I did the other one. All I did was replace my cosine 2x with 2 cosine squared x minus 1. I'm just going to rearrange it a little bit. So I've got my cosine squared first, then I have my cosine, and then I have my minus 1. If you look above, this is almost identical factoring, but instead of having it 2x squared minus x, it's going to be 2x squared plus x, but still minus 1. 2x squared plus x minus 1. I can factor that. So it'll be 2x and x, still going to be 1 and 1, but this time my plus needs to be back there and my minus needs to be up here. As you can see, it's almost identical to the last problem, just a weird one little sign off. So we got to make sure that we're careful with that. And replace my x's with cosines. Two cosine x minus 1, cosine x plus 1. And then just like we did last step, set your factors equal to 0 and solve. Let's solve these out. Add 1 to both sides. Divide by 2, I get 1/2. Well, I've already done cosine of 1/2, and that was at 60, which is pi over 3, and then 300, which is 5 pi over 3. And then cosine x of -1. We did +1, but -1 is just the opposite side. That's 180 or pi. Okay, I got one more. Everybody buckled up for one more? Okay. Last one. Sine 2x equals 2 sine x. Let's replace my sine 2x again, just like we have before. This one becomes 2 sine x cosine x equals 2 sine x. While we're tempted to divide everything by 2 and divide everything by sine, you can't do that. Move your 2 sine over to the other side. Two sine x cosine x minus 2 sine x. What can I do? What can I do? Factor. Take out a 2 sine x. Very good. Take out the 2 and the sine. So I'm left with just cosine x minus 1. And again, set both of our factors equal to 0. Let's see. 2 sine x equals 0. And cosine x minus 1 equals 0. Two sine x equals 0 is still just sine x equals 0. So where is my y 0 again? Zero and 180, which is pi. And then I add my 1 to both sides, so cosine of x just equals 1. So where does cosine of x equal 1? That's -1. 0. Just 0. Okay. We did not finish 5-4, so 5-4 is not due yet, but 5-3 is due. I only have like one more side of notes. I only have 4 problems to do with you guys tomorrow. I'm not getting into 5-5, so any extra time, we will go over homework. I have an extra review sheet if you need more practice problems. I have, I can go over the extra credit sheet that I gave you guys on that virtual day. So lots of things to kind of go over tomorrow. No need to kind of rush ahead. We are looking at another quiz, I think on the 16th. I think next Wednesday is what I wrote on Schoology. Yeah, Drew? Yeah. Uh-huh. Yes. And I'll pass back to you. Let me see what I see on my end, okay? Because I can see if she started it. All right, we're ending this.